All right, everyone, let's talk about factoring using quadratic forms. So here's what we mean by that. This expression right here doesn't look like a quadratic, and we could at least do some initial steps, right, which would be to put it in standard form, x to the fifth minus 9x cubed plus 20x. Great, still not helpful. Now you might notice that there's a common factor, and so that helps. We can take out a common factor. Okay. And we're up to that this is x times x to the fourth minus 9x squared plus 20. Now here's the deal. This is still not a quadratic, right? It's not x squared plus or a times x squared plus b times x plus c. Except also it kind of is at the same time, all right? So here's what I mean by that. Quadratic has the form, right? A x squared plus bx plus c. Really, you know, this x can be whatever. It's just a placeholder. It's a variable, so that's what it is. It holds the place of something. I don't know what just happened. Okay, let's see if the pen issue sorted out. All right, so ax squared plus bx plus c is really just a times something plus b, or a times something squared plus b times that same thing plus c. So if we can force something into that format where it's, you know, something squared plus b, you know, plus something times that same x plus a number. So again, a something squared plus b something plus c, then it's a quadratic. And so that's what we have here with this problem, because this is really okay. So x to the fourth minus 9x squared plus 20 is x times x squared minus 9x squared plus 20. Right? So we've got these forms here. We've got that this is the real quadratic we're looking at. Blank squared minus 9 times blank plus 20. So if we factor that, then we're able to factor this whole thing. All right. Now, the traditional way of doing this is then you find a new variable to replace it out for. Right. So I'm going to write this as this in parentheses expression, kind of off to the side, as y squared minus 9y plus 20. And you just factor that thing using whatever strategy you prefer. So it factors as y minus 5 times y minus 4. Y minus 5 times y minus 4. But since y is x squared, we then kind of like swap it back in, and suddenly you have x times x squared minus 5 times x squared minus 4. And you might then be able to factor it further, because x squared minus 4, you then notice is a difference, or I notice is a difference of two squares. And so that would factor as x plus 2x minus 2. So this becomes x x plus 2, x minus 2, x squared minus 5. And x squared minus 5 doesn't factor further because 5 is not a perfect square. It does have, plus and negative the square root of 5 as solutions. But yeah, anyway, that's it. That's factoring using a quadratic form. So let's look at one other one, and I'm going to kind of go through it in the same way. So this is a quadratic form. We've got, this is really a squared minus 22a plus 40, where a equals that whole x squared minus x thing. So we factor a squared minus 22a plus 40 as whatever that is, 4, 10, but yeah, give me a second. As a minus 2, a minus 20, right? But a is x squared minus x. So then we sub it back in, and this is x squared minus x minus 2 times x squared minus x minus 20. And you notice that they're also both quadratics, and so those can also both be factored. So x squared minus x minus 2 is x minus 2x plus 1. And x squared minus x minus 20 is x minus 5x plus 4. So this quadratic form thing, ugly looking thing up top, turns into 4 linear factors once you've substituted in and then back in. That's it, right? So these are quadratic forms. They aren't actual quadratics, but they can be substituted in so that they become quadratics. Then you substitute back in the expression that you took out and do any remaining factoring with what's there.